Hello, this lecture is on definite integrals, but instead of doing the antiderivative, what we're going to do is something called Riemann sums. And some of you may remember this from last year, and I think I heard some of you saying you didn't like it, but I feel like you should like it because it's the easiest math that you'll encounter in calculus. The formula is basically of rectangles and trapezoids. The Riemann sum stands for a sum of a shape, whether it's a rectangle or trapezoid, trying to estimate the area under the curve. And some of you saying, why do we estimate it? We already know how to find the area of the curve. Well, this is just another way to find it if you weren't able to take the antiderivative and you were given a graph. So first of all, just so that you're aware of what the formulas are, a rectangle has a formula of, in this case, we're going to do base times height. And trapezoids have here I'll draw you a trapezoid. Some of you may have forgotten the formula of a trapezoid. A trapezoid is actually just like a rectangle, except for the bases. The bases are of different length. So what it really is still base times height, except for it's the average of the bases. So base 1 and base 2 and divide by 2. So the average of the bases times height. So you can see rectangle and trapezoid have the same formula, except for one has like different sided bases, so that's why I say the average of the bases times height. You can even use the same formula for rectangle, except for the average of the bases will be the same thing for both ones. So let's first look at what it says here, the right Riemann sum. The right Riemann sum says, it's right here below, and I'm going to approximate the right Riemann sum with 3 subintervals of equal length. So if you look at my graph here, I want to have a Riemann sum, and it says here from -2 to 4. So let me just mark -2 to 4 right here. And I want three equal subintervals. It says right here I want 3 subintervals of equal length. So what I'm going to do is you'll notice that this length down here that I've marked off from -2 to 4 has a length of 6. So my rectangles are going to be of a length of 2. So I need 3. It's 6 long, and divide by 3, it's like 2. So here are basically where my 3 rectangles are going to be. Rectangle 1, rectangle 2, and rectangle 3. For a right Riemann sum, to figure out what the height of is, you basically are going to start at the rightmost. You're going to start at the rightmost. Oops, sorry. Let me move this. You're going to start at the rightmost point, go up to the graph, and then go over. Okay. In this particular case, the dot is at the x-axis, so it looks like a flat rectangle. Again, I'm going to, well, how about this? Let me change that. Start at the rightmost endpoint and make a dot. And then you're going to go over one more and make a dot to the next part of the rectangle, and then make a dot here. And I'm not going to make a dot at the first hash mark, and you'll see why. So you start at the dot, at the rightmost dot, so I'm right here at the rightmost dot, and I'm going to make a line across over to the next line. Then you're going to go up, and again, you're going to go right over and down. So again, I did that for the first one, so it was like a 0 height. And the last one, how about this? Let me change the color on you. I'm going to start at the rightmost dot, go up to the line, and over and down. Go up to the dot, over and down. And lastly, go up to the dot, go over and down. So I have my 3 rectangles. Okay. Rectangle 1, you can tell is just a line. This one has an area of 0. Okay. This one, I have a base of 2 and I have a height of 4. So this rectangle right here has an area of 8. And this one over here, it has a base of 2 and a height of 1, so this is 2. So by the right Riemann sum, this area under the curve is 10. And you can tell it's a terrible estimation, right? I mean, this one, the first rectangle, has a 0 height. Like, this is a very poor representation if I'm trying to guess how high or how much area is underneath the curve. Okay. So what I'm going to do is also I'm going to put this in formula. I'm going to put this in the Riemann sum formula form. What you do, as we've been doing, is the base, which is 2, times the height. For the first rectangle, it's 0. The base of 2 in the first rectangle is a base of 4, plus base of 2 and a height of 1. So this is rectangle 1, rectangle 2, rectangle 3. So all I've done is base times height plus base times height plus base times height. Or the Riemann sum formula for the right side is whatever the base is, and I can basically factor out the base, and it's the right endpoints, or how about this? Endpoint 1, endpoint 2, right endpoint 1, right endpoint 2, plus dot, dot, dot. So basically start at the right and keep going until how many rectangles you need. Okay, so that's like my formula for right Riemann sum. Now, the left Riemann sum, same thing. I'm going to start at the left. This one, again, I need 3 subintervals. So I'm going to make of my length of 6, I'm going to make this into 3 rectangles. I'm going to make a dot at the leftmost, a dot at the next one, and a dot at the next one. Okay. Then by Riemann sum, I'm going to go up to the point, then go over and down. Go up to the point, go over and down. And the last rectangle, go up to the point, over and down. And hopefully we have a better estimation than the last one. Again, the formula is the base times height plus base times height plus base times height. So I have a base of 2. In the very first one, I have a height of 5. Plus, my second rectangle has a base of 2 and a height of 1, plus a base of 2, and again I have a height of 5. So this particular problem, I have an estimated area on the curve of 10 plus 2 plus 10 of 22. So one estimate, I had 10. Oh, haha. So if I look back here, sorry, that middle rectangle had a height of 5. So really, this should be 12. So doing one side, I had an estimate of 12. Doing on the other side, I have an estimate of 22. So you're probably guessing like, oh, maybe the area in the curve is probably like half of that or an average of that. Okay. And again, just so I could show you, because you're not always going to have this graph, the formula for the area under the curve with the left Riemann sum is the base. And then again, it's going to be left endpoint 1 plus left endpoint 2 plus dot, dot, dot. So basically I'm trying to say like this left Riemann sum, I could have written the formula as 2 parentheses my 3 endpoints. 5 plus 1 plus 5, and still got the same answer. Now I'm going to do these kind of the same way. So 2 more. What if I did it by the midpoint? So some of you are saying, okay, these estimates are very bad. So here's an even better estimate. It's called the midpoint. This particular problem, same graph, same number of rectangles. I'm going to do my hash marks again because I need 3 equal rectangles. Sorry. And then instead of making the dots at the endpoint at the right or at the left, what I'm going to do is I'm going to make a dot in the middle of each of the rectangles. So you see here in the first rectangle, I have a hash mark here and here. So I'm going to put a dot right here because it's in the middle of the rectangle. By the same token, here's hash mark. I'm going to put a dot here because this is the middle. And the last one, hash mark, here's the middle. So to do a midpoint rectangle, what you do is you start at the point. So I'm going to start at this first point, and you're going to make a line to the left and the right to make my rectangle. So line to the left, line to the right, and there's my rectangle. Line to the left, line to the right, there's my rectangle. And last one, line to the left, line to the right, and down. Okay. And now I'm going to show you how to do this with the formula way. Remember, I have a base of 2. Okay. And then I'm going to do parentheses, and all I'm going to do is list down all the points that I had, or all the points that I dotted. So last time I did left, the first time I did right, the last time I did left, and this time I'm just going to write the middle. The first middle point has a height of 2. The second middle point has a height of 3. And the last midpoint has a height of 4. So this one, if I multiply this, I get 2 plus 3 plus 4, which is 9. And 2 times 9 is 18. So as you're probably guessing, I'm getting even better at estimating. Okay, so step 1, we did the right, and I did my endpoints. Step 2, I did the left. and did my endpoints. And now I did my midpoints, and my estimation seems to be getting very, very close to what the real thing is. Now, the very last one is called trapezoidal sum. And you're probably saying, how do I do a trapezoid? All right. So same thing, same question, same graph, same process. Hash marks here because I want 3 rectangles. So those are my 3 rectangles. I'm going to put a point at every hash mark. So point here, point here, point here, and point here. So in the past, I only did 3 points. 3 points for left, 3 points for right, 3 points for middle. Trapezoid, you're going to do 4 points. Okay? And this is what you do. First of all, you're going to make a line up to every point. So line here, line here, line here. And this one is barely a line because it's 0. And then you're going to draw lines that connect all the dots. So the very first thing I'm going to do, and again, it can't be so straight since I don't have a ruler, but there's the first one. Here's the second one. And here's the third one. Okay? So I have 3 trapezoids. One of them looks like a triangle, but I'm going to show you how to do this in a trapezoid way. Okay, remember, for the left, right, and middle endpoints, we did the base, and then we did left endpoint plus left endpoint plus left endpoint. Or some of them we did right endpoint, right endpoint, right endpoint. Or for the last one, we did midpoint, midpoint, midpoint. Okay. So now you're saying, like, how do I do this for a trapezoid? A trapezoid is still the same thing. So basically, I did that. What you're going to do is still the same thing. It's going to be a base. And then the inside, I'm going to average the heights. Okay. So the very first one, you're going to do height 1 plus height 2 and average it. Plus height 2 plus height 3 and average it. Plus height 3 plus height 4 and average it. Okay. So all I'm going to do is the same rectangular formula except for I'm averaging the bases. For this particular problem, as we've seen many times, this base is 2. Now, in this one, my first height is 5. As you can see, here's height 5, and I have a height 1, and I'm going to average it. Okay, height 1 and a height of 5, I'm going to average it. And the last one, I have a height of 5 and a height of 0, and I'm going to average it. So by trapezoid rule, I have 2, 3, plus 3, plus 5 over 2. If I distribute this, I have 6 plus 6 plus 5. I have an estimate area of the curve of 17. So even better estimate of my formula. So this whole section, and we'll practice many times, is how to take the Riemann sum of a function. Again, not all functions have a formula, so that's why I can't always use the antiderivative formula. If I have a graph, I'm going to have to use a Riemann sum. So I'm going to show you a couple of examples so you can see what this looks like when applied. And for the AP test, you see at least 2 or 3 of these problems. So you're going to see these problems for sure. So here's a school carnival that sold raffle tickets between noon, time equals 0, and time equals 8. The number of raffle tickets sold t hours after noon is modeled by differential function r for 0 to 8. The second derivative is less than 0 for all t. Values of r of t and hundreds of tickets at various times are shown below. First question says use a trapezoidal sum. All right. So remember, in this particular problem, I have no function. I can't take the antiderivative of this. So it says take a trapezoidal sum. Now, you might want, most of you, as you're starting to do this, you might want to do a graph, but it takes too long, especially for the AP test, to do this in a graph. What you want to do is write the formula. The formula for trapezoidal sum, if you remember, was base times average of the heights plus average of the heights plus ... and so on. Okay? For this particular problem, you'll notice it says I want you to go from 0 to 8, okay, and 4 subintervals. So again, my base is going to be 2. I'm going 8, and I want 4 subintervals, my base is going to be 2. So this is going to be 2. Okay. And then I'm going to average the heights. This one is my x-axis, hours. This one's going to be my y-axis, how many hundreds of tickets were sold. Okay. So let's plug in the formula. Height 1 is 0 plus a height 2 of 5. And I need to average that. So in case you're wondering where I got that, here's height 1 and height 2. Okay. Then the next one, this one's height 2 and this one's height 3. So 5 plus 9 over 2. Height 3 plus height 4, 9 plus 10 over 2. And last one, 10 and 11 all over 2. You may notice because the base is 2, all of the denominators will cancel when I distribute, which is very nice since I have a base of 2, all the denominators cancel. So if I multiply this out, distribute this, distribute this, distribute this, distribute this, these cancel, these cancel, these cancel, these cancel. So after my trapezoid formula, the height is 5 plus 14 plus 19 plus 21. And I'm going to get 19 plus 19, which is 38, plus 21, which is 59. So what you just found, again, is how much, how can I say this? How much tickets you've sold overall. Okay, so this table told us how many tickets per hour we sold. Like in hour 1, we sold 5 tickets per hour, et cetera, et cetera, et cetera. So this tells me how much we sold overall. Okay. Now it says, does this approximation overestimate or underestimate the actual value? In this particular case, it's hard to tell since we don't have a graph. So don't worry about this question. I'll explain that when I see you in class. Okay. Now, same question B, but it says I want the right Riemann sum. All right. The right Riemann sum formula, remember, is base. So we're going to go right endpoint plus right endpoint, and you're just going to keep on going until you have as many rectangles as you want. This one, it says I want 4 subintervals. This one says it's from 0 to 8. So again, I'm going to have a base of 2. Okay. So in this function, if I erase this real quick, instead, I'm going to go, here's right endpoint 1, right endpoint 2, right endpoint 3, and right endpoint 4. So plugging into my formula, I'm going to get 11 plus 10 plus 9 plus 5. And again, I'm estimating by the right Riemann sum. So I start from the right and get my first 4. Okay? I am not counting this one because I'm doing a right Riemann sum. I just take the first 4 from the right. So if I add this all up, I'm going to get 21, 30, 35, and I get 70 for my right Riemann sum. Okay? So you can tell like these right and left Riemann sums are very inaccurate. Okay? And it says using correct units, what the heck does 1/8 0 over 8 mean? So what this means really is when I took the Riemann sum, I told you I'm finding all the total number of tickets I sold. And if I divide by 8, remember there's 8 hours, I'm basically giving you an average. Let me write this down. I'm giving you an average of tickets sold per hour. Because remember, this graph only gives me from hour 2, hour 4, hour 5, hour 6, hour 7, but I don't see hour 1, I don't see hour 3, hour 4. So I'm estimating how many tickets I've sold because I wasn't able to see all the time how many tickets were sold. So that's why I get a good estimate. That's why they use the Riemann sums. All right, last example. During the time interval 0 to 12, water is pumped into a swimming pool at the rate of blah blah cubic feet per hour. This table below gives values of P of t, a strictly monotonic differentiable function, blah, blah, blah. So basically, I'm just pumping water. At time 2, I'm pumping at 12 feet per hour. At 4, 20 feet per hour. All right. This problem says, using the correct units, what does this mean, and what does this mean? All right. Again, the antiderivative tells me the total number of something. So if I see 0 to 12, I'm finding out how much cubic feet of water did I put in. So I'm going to do cubic feet. of water pumped from 0 to 12. So again, what the antiderivative means is the total amount of something. So if this one is cubic feet per hour, I'm pumping it at cubic feet per hour, this tells me after 12 hours how much water is in the pool, or how much did I pump in, okay? This particular one with a 1/12 in front of it, remember this tells me the average. So even though I pumped in, like say for example, I pumped in a million feet of water, divided by 12, divided by 12 hours tells me how much is in there per hour, okay? So I'm just gonna add, I'm gonna cheat here, blah, 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 per hour on average, okay? So that's what the difference is between that and that. Okay, B says use a midpoint Riemann sum. Okay, so I want the midpoint. And I want 3 subintervals from 0 to 12. All right, so from 0 to 12, I want 3 subintervals, which means my rectangles are a length of 4. So to start this off, I'm going to do base. And remember I'm going to have 4 midpoints. Midpoint 1 plus midpoint 2 plus midpoint 3 plus midpoint 4. I know that this is a length of 12 and 3, I'm going to have a base of 4, like that. So those of you that are visual learners, again, there's not going to be time to graph it. Let me show you how this looks like. I'm going to have so basically what I'm going to have is this particular function, but I need to divide it by 4. Okay. Now, if you have 12, okay, and it's divided by 4, or sorry, you have 12 and it's divided by 3, you know you have a length of 4. So here is, again, if you're a visual learner, here's rectangle 1, okay, here's rectangle 2, and here's rectangle 3. Okay, so basically 0 to 4, 4 to 8, 8 to 12. I'm splitting up into 3 rectangles with a base of 4. So if this is the case, if I'm going from 0 to 4, would you agree with me, or could you understand that the midpoint is going to be halfway? So for 0 to 4, the midpoint is going to be 2. From 4 to 8, my midpoint is going to be 6. And from 8 to 12, my midpoint is going to be at 10. Okay. So I guess I messed up here. This is only supposed to be 3 subintervals. Sorry about that. So my midpoint at 2, the height is 12. With a midpoint of 6, my height is 25. And with a midpoint of 10, my height is 50. So to do the midpoint Riemann sum, I'm going to get 4. 12 plus 25 is 37, plus 50 is 87. I don't have a calculator on me. 348. And again, I need to have units. So basically, my estimation is that from 0 to 12, I pumped in 348 cubic feet of water. Okay, pretty good estimation, if I may say so myself. Okay, last question, the left Riemann sum. This one, if you're careful, 6 subintervals. And I want to estimate 1/12 of this, and I'm going from 0 to 12. Okay, so let's do this. Left Riemann sum, the formula is base, and then I have the height at left endpoint 1, and again I have 6 subintervals, so like I'm going to do this 6 times. If it's going from 0 to 12, and I have 6 subintervals, my base is going to be 2. And if I look at my formula, or my table here, basically, here's left endpoint. Here's left endpoint 1, left endpoint 2, 3, 4, 5, and 6. Those are my 6 left endpoints. Okay, so I'm starting from the left, and I take the first 6. So I've got 0 plus 12 plus 20, 25, 30, and 50. Okay, so those are my left endpoints. the heights at the left endpoints, and then I have a base of 2. I'll add these up. So I've got 12, I have 32, 57, 87, 137. And I have 274 cubic feet, okay, of water that was pumped in. Now the question is, what does the 1/12 mean? Again, if I divide by 12, I'm taking the average per hour of how much cubic feet of water is pumped in. So hopefully you understand left, right, middle, and trapezoidal sums. It's not supposed to be very difficult. Again, the math is very easy. You just have to remember the different formulas. So like left endpoint, you start from the left, 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 left. Right, you start from the right, 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 right. And then middle, you find the middle and find those heights. And the trapezoid, you average the bases. So I'll give you some time to practice. And if you have any questions, feel free to ask me. So hope you enjoyed the video and take care.